Hello everyone. My name is Kamlesh. The project I'm working on is hardware implementation of the neural network architecture with my guide Anita Angelan ma'am. The objective of our project is to design a neural network architecture that with an high speed and a low power consumption. In order to validate a neural architecture, we're going to design an AND gate which realizes the function. Our motivation is just production of the edge application with the deep learning techniques. The edge applications, when combined with neural architectures, enables high speed and reduced power consumption in portable devices. They also reduce the bandwidth consumption, also the time delay for data transfers and processing by processing them in the local server rather than going back to the cloud. So as many applications have restricting performance in them due to the enormous data produced by many computing systems, this required for the neuromorphic computing, which uses a new algorithm approach in which they are modeled it after the human brain and the nervous system. And also, SNN models are efficient for faster data transmission in the continuous real time and also they are successful in adjusting to the new environments. This leads us for the deployment of the neural network architecture in this project. We have done various literature surveys on neural models where in this neuron model they have implemented neural architectures as well as the sub models that sub circuits that are required for the implementation of this neuron models. So we also done papers on semi-custom designs that is FPGA and also in custom designs. So we'll just understand the design methodology. So this is the neural network basic architecture. So we can see there's an input layer, hidden layer, and output layer. After receiving the information from the input layer, it processes it and sends to the hidden layer, which is later on passed on to the output layer. The number of layers can vary on depending on the architecture design that is required for each computing system. So, as we understand the basic neural system, it is required to understand the artificial design of the artificial neuron, which can be employed in each layer. As I said before, the neural network actually mimics the working of human brain and the structure of the nervous system. So we can in this figure shows how the similarity between biological neuron and artificial neuron, which we can infer that the artificial neuron has been following the process flow of the biological neuron and been deployed according to that. As the inputs and the products of inputs and weights are formed as a synapse, which is then sent into the main function of processing called the adder and the activation function, where different inputs and weights products have been added together and sent into the activation function to receive as an input output. This adder and the activation function are generally composed same as the biological neuron part called soma. So as we came to know, learn about the after artificial neuron, uh, in order to validate our artificial neural network, I implemented an AND gate model. So this AND gate model is modeled in a way that is in the in so that it gives out the correct input, which with we can confirm that the artificial neural function we designed is working correct or not. So we can see that the AND gate model requires various subsystems such as Gilbert multiplier, adders, and activation function. These are the basic subsystems that are required for the neural architecture to get the input data and process it. So we understood this. We have designed these three subsystems. One is the multiplier, where multiplier is the multiplier chooses an analog multiplier, which takes in differential outputs. In order to differential inputs and outputs, in order to get it into a single output, we have also employed a subtractor. The process flow has been shown in this figure. So this is the block diagram of a Gilbert multiplier, where it has four regions and two inputs. These two inputs take in the two inputs taken the values and gives an output proportional to the product of these inputs. Namely, V in and VU gets are the input, which gives out a product in the form of differential output OP1 and OP2, which is then later passed down to the subtractor circuit, which is a two-stage differential amplifier, which reduces the differential output into a single entire output. Then next is passed on to the activation function. Activation function is actually an essential circuit in many neural network, because they convert any input and give them as a simplified output, which is then later on passed on to the each and different layer. You can see the mathematical formula for the activation function is 1 plus e power minus z, where z is the input of the function. The transfer function of the segment function is an S shape. Considering this S shape, deployed on simple differential amplifier as an activation function, as it also has the same transfer function. It also saturates a high input and low output, the same as the sigma activation function. Also gives out a non-linear relationship between the input and output. This makes it as an app circuit for employment of an activation function. They are simulated in a cadence technology using 180 nanometer technological library. It is the design and the simulations of the transient and the DC channels are done using ADEL environment at a nominal temperature of 27 degrees Celsius. This is the cadence simulation of a Gilbert multiplier. As you can see, the topmost and the bottommost in the graph are the differential outputs that are meant to pass on to the subtractor circuit to give it as a single output. So we are given a bitwise multiplication for the Gilbert multiplier. This bitwise multiplication actually can act as an AND gate, which that the validation of this circuit will be more easier. As you can see, when the both outputs are high, it gives out a logic high as an output, which resembles the working of subtractor circuit and uh, uh, multiplier as the same. Next is the final, the objectified simulation of the AND gate model. By making all these designs of blocks into symbols and integrating them to one, we can design this neural and artificial neural network into an AND gate model, where the weights and the bias have been predetermined to check the validation of the function. As you can see from the structure, each weights and inputs have been passed on into the multiplier and all been formed into a junction. Just because the output node of the Gilbert multiplier acts as an adder, so it adds all the values and sends it to the activation function, which gives out the final output. As you can see, uh, the top and the middle are the inputs to the AND gate model. The first one is the 0011, and the second input is the 0101, which follows the truth table of 000110 and 11. You can see when both outputs are high, the model has been able to give a logic high, stating that it works as an AND gate model. Hence, the artificial neural network has been validated. This is the simulated results of each subcomponent and the integrated AND gate model. The Gilbert multiplier gives out 107.8 microwatts, and analog model subtractor gives out 1.35 microwatts, and activation function gives out a power consumption of 102.8 microwatts. With this, all the integrated into an AND gate model, which gives out an average power consumption of 42.4 milliwatts. So the neural network has been discussed, and about its understanding of how it is working and how it integration with edge techniques are also being discussed. Different subclass have been studied, which are required for the implementation of the artificial neural network, and all have been simulated and the outputs have been verified. The AND gate has been designed in the cadence and 180 nanometer technology, and validation has been done. The power dissipated for the structure has been recorded to be 42.4 milliwatts, as discussed above. This neural network can be enhanced further in the future by incorporating into an SNN model. The spiking neural network basically consumes less power for a computational technique, as it circuits the trigger only when it receives the data in the form of a spike. Hence, this can reduce the unwanted power consumption, and it will turn the circuit into a more power efficient circuit. Thank you.